Number 7 then from the 2018 SQA Higher Maths Paper 1, 8-mark question. A decent chunk of marks come from this one, and it's this one about the curves and tangents to the curves and intersections. That's one you should be prepared for. You've got this curve with this cubic equation here. It cuts the y-axis at a certain point P. A line is drawn as a tangent to the curve at P and then carries on and cuts it at Q. It's everything in the question. But first of all, for just 1 mark, it says write down. So you don't need it, there's no calculation. Write down the coordinates of P. So P is going to be the point, and make sure you put a point down. Don't just put down the number where it crosses. It doesn't say write down the y-intercept. You can tell from the equation. It crosses the y-axis when the x's are 0, so you're just left with 5. So when x is 0, that's 5, and that's a mark. So part B then, determine the equation of this tangent then to the curve at P. Well, the tangent's a straight line. To get the equation of a line, you need 2 things. You need a point on it, so that'd be the point P, got it, and its gradient. Now, since it's a tangent, it's grazing the line there. The gradient of the line will be the same as the gradient of the curve at that point, and the gradient of the curve is given by its derivative. So the first thing you'll need to do is differentiate that. Because once you've differentiated it, that means you've got the gradient. So differentiate it, multiply by the power, take 1 off the power, multiply by the power, take 1 off the power, and if it's a linear term, it just goes down to the constant, and 5 doesn't change, so it's gone. So there's 1 mark for differentiating it. Now, to get this gradient then, you'll need to know an x coordinate at that point, and you do the x coordinate 0. Well, I don't know if we need to show that or not. 3 times 0 squared minus 6 times 0 plus 2. That means the gradient's just 2. Getting 2 gets a mark. Now you can jump in. Now, just again, that line there, you could go in with y minus b equals mx minus a, but always double check if it's not a simpler line than that. Is it vertical? So the equation's x equals. Is it horizontal? So the equation is y equals. Do you know where it cuts the y-axis? Yes. So you can just say y equals mx plus c, because you've got the 2 figures to put in. So y equals, the gradient was 2, and it cut at 5. There's the last mark. You can do y minus b equals mx minus a if you like, and it will give you exactly the same answer. And of course you can rearrange that into any form you like. Y minus 2x equals 5, or put them all over to one side, it makes no difference. Part C then, find the coordinates of Q, where this tangent at P continues and meets the curve again for 4 marks. Point of intersection. At a point of intersection, the 2 equations must give the same coordinates for the point, so the y must equal the y. So straight away you can say that this expression here, x cubed minus 3x squared plus 2x plus 5 must equal this expression here that you got in part B, 2x plus 5. Now, you're not getting a mark yet until you've brought it all over to one side. Right, okay. So you've got x cubed. You've got minus 3x squared, but notice these parts cancel out. 2x takes away the 2x, the 5 takes away 5, so you're just left with this simple thing then. This simple little expression. That gets a mark. Now you have to solve it. It's all over to one side. Make sure you put equals 0. It always mentions that in the marking scheme. I don't know why, but they just like, as long as you mention it once apparently, but you should mention it all the time, it's relevant. Take out a common factor. X squared comes out, leaving an x minus 3 equals 0. So factorising gets a mark. Now you're going to get 2 answers. You've got either x is 0 or x is 3. Well, the quote for Q, x would have to be 3. So at Q, x equals 3. I'll give the reason, but I don't see this in the marking scheme. Since at P, that's the one that had x equals 0. You could tell anyway that that x equals 0 belonged to a tangent because that's a double root. Look, it's there twice. Now, stating the x coordinate of Q, knowing which one it was, I would have said I'd also given a reason is worth a mark. Now to find the y coordinate. Well, you can pop that 3 into either equation. I'm going to pop it into this one. So it'll be 2 times 3 plus 5, which is 11. Now apparently that's sufficient then. Y equals 11 does, but I like to finish it off. So Q is the point, 3, 11. No, there. No, I'll let you have it there.